Okay, welcome folks. I'm really happy to be with you. I'm Glenn Schuster. My background's meteorology. I'm one of the two main authors for marine science with a math background in meteorology and many years actually teaching in the classroom as well, integrating math and science. I'm proud to present marine science. Dr. Megan Marrero is a biologist out of her undergrad is Cornell, and she's got her doctorate in science education in ocean literacy at Teachers College. Karen Woodruff is an environmental scientist and educator, and Catherine Taylor is a learning scientist and really strong with instructional design. U.S. Satellite, we've been around over 20 years with lots of funding from NASA and NOAA. We have moved into now, we've evolved from a middle school work that has been grant funded by NASA and NOAA to a full-blown marine science high school course for Pearson, and we are very pleased about it and to deliver it. So let's talk to it, and I'll take you through it and show you a little bit of what it's made. It's an integrated, cutting-edge way to learn content, earth, life, and physical. There are great technology tools. One of the strengths is the use of data, as well as learning in context. We're learning in the context of the ocean, and it really is integrated STEM. If there's anything that's more than one click or two clicks, it's not in this project, so it's very easy to pick up. I'll talk about the overview and a little background and share with you the elements and the material. We shared with you the top 5 reasons that you might want to pick up marine science. It is a bona fide high school offering. It can even be a lab science. It's a year-long course, and because of the way it's structured and the content is important for students to understand concepts and to look at research and analysis, I think that it's best if it is a year-long course. And technology is really seamlessly integrated to promote scientific literacy and inquiry skills. Next generation science standards is terrific with this, as well as Common Core, particularly because of the writing of analysis journals, and it's very easy to use. So in addition to the content, there's a research and analysis component. It's phase 2. I'll go over the phases. And using simple-to-earth imagery to explain the movement of animals tracked by satellite, both real-time or archived, is the hook. And there's something for everyone, as I think you'll see. Again, the use of data and its simplicity is kind of special here. So phase 1 is, again, really the content, understanding ocean and its processes. We're going to take a look at the table of contents shortly. Research and analysis, where students become experts in either the species or sets of images, like sea surface and imagery that goes with it, phytoplankton and chlorophyll, as well as bathymetry. So they will observe and they'll justify animal movement. The socio-scientific issues are seen in phase 3, understanding how humans impact the ocean. Here's a picture of the elements of marine science. There is a student text. There is a teacher edition text, and I'll show you a chapter or two in that if you haven't seen it. The wrap of the teacher text is usually not necessarily really needed when performing instruction and facilitating inquiry, but in this case, we think it is important. There is a DVD with over 1,000 assets, some of which you'll see today and are now online, as well as nearly 100% of the assets which are online. I think I might have messed that up, but the contents of the DVD go on the network in the school. Everyone has access to it, and about 100% of what's on the DVD is also available online for students. And there is an exam view for exam questions. So the DVD and the internet interface both look a little bit like that. The phase 1 content, again, is on the DVD, and I put this here because of eTools. eTools is when you're facilitating a lesson, you'll see that you will want to go into whichever lesson you're in. The lessons are really chapters. They run 1 to 2 weeks generally. And again, there are the 3 phases. The second phase being research and analysis, where there are tracks of sea turtles and whales, polar bear, penguins, and more on the images. So in phase 2, with animal tracking as the hook, I think what's very special are the way students can make connections. This is a ground floor way in which you can look at college level or higher data. You can see students analyzing data. This is a sea surface temperature map. There's a lot of content in that. There's heat and energy transfer. There are seasons and currents, density. There's a lot of good science. And when you can superimpose or put the currents on top of that, you really basically have a great opportunity to make wonderful connections. Polar bear, one of the favorites, was data from 2008, 2007 and 8, I believe, when we were real time with the polar bear. And the sea surface experts have access to sea surface, weather, sea ice, sea height, currents, and wind. Little, I think I'll change to blue. A little bit of, little counterintuitive, because when we look at sea ice concentrations, the higher the concentration, the more the sea ice is. So it's funny, but looking off the north coast of Alaska, there are a number of polar bear, and if I zoom in, keeping in mind that we're looking at an image that is sea ice concentration in April, what students might discover, they always discover, the scientists will discover at the same time. This April, you look at this animal, and you can see that the polar bear is on the highest concentration of sea ice. So whether students look at imagery weekly, every other week, monthly, they can write chapters about animals for time frames and write about elements in their case studies. I'll show you this online, but the simplicity, here's the toolbar. You can look at the one or more animals. You take average, you get the map, and what you'll see, and I can show you in a moment, is that if you're looking at a September 20th map, then the date closest to September 20th for your animal will be flashing. And of course, you can look at these different parameters as well. So I want to show you some of the data, but I don't want to get bogged down in the data because it's not all about the data, but whether you do a little bit or a lot of the data, there's so much to do. This is bathymetry to demonstrate California sea lions and maybe their dependency on the ocean floor into where they are. Elephant seals. Elephant seals off the coast of, we have California sea lions too, off the coast of California, their movement, and on top of phytoplankton imagery, thinking of food. So the biology of the ocean is seen here, and connections are great. Humpback whale, they migrate. So student might say moving to the feeding grounds and write about one of the chapters when they're taking their observations and their analysis. In the future, we're going to bring back a wonderful feature where we had scientists that interact with the student journals. You can also interact with the student journals as well. Let's see. Again, the socioscientific issues. There are a lot of opportunities after the content's learned for students to learn and apply data to real-world problems with cutting-edge integrated data and tools. Here are some examples of data, and whether they're in the field or they're getting it online or they're interpreting some Excel data we provide for them, there are a number of issues in Phase 3 that are explored. So Dr. Marrero's research out of Columbia was challenging, but she demonstrated that students increased their process skills, blended with their content with the ocean. She found and looked at the fact that folks who are on the coast, students and teachers, want to learn this just as much in landlocked states as well. But a more systems thinking approach developed. So the ocean is one ocean, and it's tied to the Earth and its system, air, life, water, and land. So there are a couple elements I want to show you as we look at the materials. There is the table of contents, which I want to pull up. It's funny, I'm not, oh, here it is. Okay, let's see. It's funny how it's not showing up on this screen. I knew my computer was having a problem. I think I'm going to do what this computer's doing well, and you know what? I can still do this because now I'm looking on this other computer, and my computer's having some issues, which I was afraid of. So students and teachers will be able to differentiate. I mean, whether they're articles that are for the highest level learners online, or students are using the study workbook to look at more data, look at vocabulary. I think that we do a great job in differentiating. We can keep it simple, or students can look at different types of maps to draw more and better conclusions and make connections. Okay, so now my computer's having real problems, which means that I am going to switch to my backup machine, which I can say probably has happened once in 10 years, but I got the blue screen yesterday, so I'm a little, just want to be able to make sure we don't, I want to make sure we do well here. So let's move forward and talk to the fact that whether you have one computer in the classroom or students can go to the lab sometimes or they need to do some of the work at home, it's important that we're like a one-click type of an environment where you can be successful in all types of learning environments. Again, I'll stick with the maps because I'm going to pop out and show you some of the materials. But Sooty Shearwater, seabirds travel far. Seabirds actually will be able to describe their movement based on weather, too. The beautiful maps, this is, of course, sea surface temperature. They travel pretty far. You can see what the concentration was with these wonderful chlorophyll maps. So here's what the bathymetry maps look like, the current maps, sea height maps, a little bit more complex, and also your wind maps. Nice to put the wind maps next to the current maps. The weather maps are wonderful, and it's fun to see the swift progress of a seabird, whether it goes through a storm or whether it finds an island and stays there for a number of days. That's fun to look at. Continental shelf and ocean fronts, sea turtles. One of the things that's really great in the book is the fact that we use the 5E instructional design, and that suggests that the elements of a lesson have an engage, an explore, an explain, an elaborate, and an evaluate section. So in engage, we want to get the students hooked on whatever the topic or chapter is. The explore might be a lab, a cyber lab. These icons really are terrific and demonstrate what the teacher's going to be able to do with the students. In the explain, it's a little bit more content-driven to explain what's happening or going on. The elaborate might have more discovery or demonstrations, hands-on labs, going into looking at satellite authentic data or some field investigations. One of the chapters focuses on the Gulf oil spill with current data, which is awesome, and it looks at uses the engineering design process, where engineering is a pedagogy, of course, and helps you to better understand the science. Students clean up a model oil spill. They participate in a debate about dispersant use. The book really is just built on the essential principles of ocean literacy, which you may have seen before that come out of NOAA, National Geographic. Just the fact we're one ocean, and these elements are what's learned inherently to understand the literacy element of it. So I'm going to try to go back to my other computer and see if it'll show me, see if it will allow me to bring up some of the elements that I have here, like the front matter. So the front matter is sometimes not too important in the book, but I think the front matter here, there's Megan and me. I think the way in which the lessons evolve are so important. Water, the ocean over time, migrations, seafloor, formation of the ocean, and then seasons. Looking at energy distribution, energy in the ocean, weather and climate, Voyage to the Deep, Photosynthesis, Biodiversity, Marine Populations, Population Changes and Evolution, Food Webs, Invertebrates, Fishes, Marine Mammals and Reptiles, Tides, and, so it's engage by discussing examples of symbiotic relationships on land. Explore by learning about the practice of conducting baseline secondary research and identifying examples of interactions between marine species, blah, blah, blah. But you can see the different activities and the cyber labs that are prevalent. So I think I'm going to share another page. Let's take a look at when you registered, you had access to this. You may have had a chance to look at the book. One of the things I want to draw out are these overviews that are in a teacher edition. They're extremely important and terrific because they demonstrate the themes and where the book is going and the chapter from which it followed or preceded. And it shows these wonderful teacher tips, shows you materials of things you would just simply pick up at the supermarket to do any of the labs. When you see e-tools, you can go online, and you can see that the text, lesson connections, activities. This is the student version. So we're facilitating so many types of things, either on the One Computer Classroom or looking at and using data at home. We're facilitating discussion. So this is not a classic biology text where you have, lots of dense text. There's a lot of dense text in some of the web links if you want to enhance some of it for students, but you'll find you won't want to. So, and it's a great looking book. Currents next to winds, winds next to currents. Let me show you let's see, I think I can pop out of this. I can't believe I couldn't advance the slides in WebEx, but I'm able to do this. Let's hope it holds up. So this is DVD. When you literally click on this icon that's on the desktop, this is what comes up, phase 1. And you can click on, I can go into this lesson 9 because I had that on there. And one of the things I think we do really well, which had never been done really well before in my opinion, are, I'll just show you one of the concepts. And there are dozens of these things, hundreds probably, but this Coriolis effect animation, and never been done well in K-12. You could think about a plane that's moving from, say, north to south from the equator, and when the plane starts, it has the memory of the equator, and this definitely has meaning for thinking about water movement. So you click play, and the memory of the equator shows up, and there's not as much distance to travel in the northern hemisphere, so you end up off to the right. So there are just dozens and dozens of simple, eloquent, one-click types of things that kids are going to really get and understand. Bathymetry, SST, let's see. I haven't clicked on this one in a while. This is elegant. April 7th, June 30th, the location of the animal. And so this is like a case study. So the students will be familiar with this type of work when they're looking at their own animals. So we talk about, what's happening and what the experience of the animal is environmentally, just for several minutes. And the kids just love it because it's change over time. We can look at any of these. This has some good ones. I love this. This is not U.S. satellites, but we have permission to use this University of Alaska Fairbanks video, which I love. And it's ocean floor processes, the tsunami, where there's transfer of energy from the crust of the earth to and through water. And you see the tsunami if you haven't seen this before. But again, all of these NASA and NOAA assets seen and utilized and integrated into STEM and content that way. And I had one more Okay, this is the web page, our main marine science web page, where you go to the National Edition. You'd log in as a teacher, and it's where you would access some resources, but also students will go to the animal movement maps and data. And I just wanted to demonstrate this because of the ease of use of it. You just would simply click on, um, you know, there are animals now. There's an increased amount of animals that are coming in this next season, but so many hundreds of wonderful tracks. I'll just click on one here. What is leatherback? Leatherbacks actually have wonderful tracks. Okay, this one's off the coast of Africa. So the geography is great. It defaults to the zoom. You click on the zoom. It's so easy to look at. I can, even though a student might be bathymetry expert and follow this over time, I might click on sea surface, and it should be able to just jump to the sea surface map. And where is it flashing? It's flashing right here. So that is the week ending 12/31. I can just change, and I will see where it was in August, and it'll change the map. We'll look at the difference in temperatures. Not so much different along, not so much different in off of Africa. But so there's just a lot of great stuff, and again, each chapter is at least a week's worth of material. So I don't think that you'll be short anything here. So let's go back and stop the sharing. We looked at the book, the web, we looked at the DVD, and I guess this little activity that I'll end with epitomizes some of the one of the lessons. So you could take a simple, you teach one of the things with data. You teach isolines, so you might draw the 20-degree isotherm. We do this in teacher workshops, and then look at all the content that you can talk to in the satellite image over time, and without seasons, it would look more like that. And look at winds next to currents, and look at real winds next to real currents, and then just talk to it in the context of a seabird like the sooty shearwater. And that's really about it. So let me see if I can't unmute you, and actually I will see if my camera works so I can say hello. I don't often do this because I find it very distracting, but hopefully it will it'll work. Here I am. Hi. So you're wait, I didn't unmute you yet. Let me unmute you both and say thank you. Do you have any
Hello.
questions? So your mics are open now.
We didn't see that last little bit you were going over about the bird migration, I believe it was in the past.
Oh, that's
We have a
the
crayon picture.
Oh, okay. That's because I failed to make the I had to jump to the backup, which I never have to do, but I did. So we were looking at this little activity, and
Yes.
this is the isoline, and I talked to sea surface temperature over time, what it might be like without seasons, comparing currents and winds on illustrations like textbook, and then looking at that real data with case studies to see the effect of winds on currents.
Mm-hmm.
So that's what I meant to show you.
Thank you.
Yeah. So do you have any questions, Michael?
I really don't. I mean, I'm intrigued. I like it. I definitely would like to try it. It looks good. It'll definitely, the use of the real-time data will be really, really beneficial. I kind of like
Great.
that. It does make it more exciting and relevant and timely, rather than just working out of a textbook or pulling things off the web randomly.
Yeah, good. I'm glad. Right, Jean?
Yeah, I like it. I am interested in what is the difference between the Florida version and your national version now?
Well, the Florida version is the first version we did. There is such a thing called a textbook adoption for Florida, so we developed a Florida book, and then when it did very well in Florida, Pearson asked if we would change a number of the examples to be more national, and then
Okay.
we added the marine biology lessons or chapters because Florida didn't have that in their standards. So Megan was able to really go crazy with her marine bio, which she loves. So
Okay.
yeah.
Interesting.
But
And the consumer, I'm sorry,
even
the
if
student work.
I was just going to say, even if I was living in Florida, I would want the national version at this point because
Hmm.
it's good. The student workbook, is that what you're going to mention?
Yeah. Is that a consumable one, or is that just different from the text?
It's consumable, yeah. It's a consumable,
Okay.
yeah. So let me just, Michael, you have my email from the email. If you have any questions, don't hesitate to reach out. And otherwise,
Sure.
please pursue your Pearson rep. And if you have any questions, let us know.
Yeah,
So
no
thank you.
problem.
Thanks for joining me.
Well, my pleasure. Thank you so much for doing this.
My pleasure. Okay, take care.